Today we're going to be looking at solving equations by using quadratic methods. Our first example is x minus the square root of 4x minus 3. The first thing you want to do is try to get the radical on the other side so that we can square it, because we know squaring undoes the radical, and when we do that, square the radical, it goes away and we're left with just 4x. But whatever we do to the right side of the equation, we have to do to the left side. So we have x minus 3 squared, which ends up being x squared minus 6x plus 9. Combining like terms, we subtract 4x to both sides of the equation, and we're left with x squared minus 10x plus 9 equaling 0. That factors quite nicely into x minus 9 times x minus 1 equals 0. Setting this part equal to 0, we find that x is 9. Or if we do this side, x minus 1 equals 0, we find x is 1. Checking our solutions, putting 9 in the original equation, we find that that does work, that is a solution. Putting 1 in the original solution, however, we find that it is not a solution. We get 1 minus the square root of 4 minus 3. It does not equal 0, so it does not work as a solution. Our second problem is 5x divided by x plus 3 minus x minus 6, all divided by x, equals 4x divided by x times the quantity x plus 3. So we have to find the LCD, which in this case is x times the quantity x plus 3. We multiply each term by x times x plus 3. And when we do that, we get 5x squared minus the quantity x plus 3 times x minus 6, all equaling 4x. Doing this foiling in here, we find that we have x squared minus 3x minus 18. Still have that negative out in front, so that makes the x squared negative, the 3x positive, and the 18 positive. Still collecting like terms, we bring the 4x over, and it's a negative 4x, so we end up with 4x squared, because we took the 5x squared minus x squared. And when we subtracted that 4x, that 3x became a negative x, and we have plus 18 equals 0. So we're going to use the quadratic formula to solve, and we plug that in, and we do this math inside, and when we do that, we get a negative 287. We know a negative square root is I, so we bring the I out. 287 is prime, so we have 1 plus or minus I times the square root of 287 divided by 8. And 287, there is no number that we can pull out that squares. Y to the fourth minus 8y squared minus 9 factors into y squared minus 9 times y squared plus 1. We know that y squared minus 9 is y minus 3 times y plus 3. We still have our y squared plus 1. But looking at this first one, y minus 3 equaling 0, then y must be 3. The second thing, y plus 3, setting that equal to 0, y must be a negative 3. Or finally, this last part, y squared plus 1 equaling 0. When we do all the math, we end up with y equaling plus or minus I. We have a nice little word problem. Jan and Jen make a table in 10 hours. Jan alone can make a table in 5 hours faster than Jen. Find the time in which each person can make a table alone. Let x equal Jen's time. So we have 1 over x is how much Jen's doing, and then Jan does that amount of work, 1 over x minus 5, because she can make it 5 hours faster than Jen. And that always equals 1 over 10. Well, the LCD of our nice formula over here is 10x times the quantity x minus 5. And when we take that times each term in our equation, we end up with 5 times the quantity x minus 5 plus 10x equaling x times x minus 5. Continuing to simplify, we take that 5 times x minus 5, and we find that that's 5x minus 25. We still have our plus 10. On the right side of the equation, x times x minus 5 ends up being x squared minus 5x. Taking all the stuff on the left side of the equation to the right side, we find that x squared minus 20x plus 25 equals 0. So this problem is continued on into our next slide, and we're given that at the top of this slide, and we're going to use the quadratic equation to solve. Plugging that in and we do this math, we end up with 300. Continuing to simplify, we'll go 10 plus the square root of 300 divided by 2, and we end up with 16.1. Or 20 minus the square root of 300, which is our 12.2, all divided by 2, we find that is 3.9. Plugging 3.9 into x minus 5, we get a negative 1.1 hours, which is not possible. We can't have negative time, so we reject 3.9 as a solution. We now try the 16.1, and that gives us 11.5 hours. So 11.1 hours. So 11.1 hours is Jen's time, and then 5 hours less than that is 6.1 hours, and that's Jan's time.